Okay, thank you very much for the invitation. After the talk on a very global scale, let me bring you to a very local scale and bring to your attention a dioxin case was coming to nationwide attention, and from which I think we have some lessons to learn. This is Taranto. This is a very nice city, apart from pollution. It's very nice cities in the southern Italy. You can see the city center is on a small island. The old city center is on a small island here. The main city is here. You see you have the dual sea situation, which is very, very unusual and very beautiful to see. This is not a lagoon, it's an enclosed seawater basin. And here you have open sea. But beside to this beautiful city, you have a large and quite unusual today industrial area where a lot of very impacting plant sit side by side, starting from the very large, this black spot is a very large steelworks, integrated steelworks. Then you have a medium-sized oil refinery and a cement kiln, which is strictly linked to the steelworks because it uses the slag to make cement. Then you have 3 waste incinerators to here, one here again, and 2 power plants that are using the waste gases from the industries to generate electricity. So you see, those are very high raw materials and high energy demand industries that have potential to release higher amounts to dioxin and PCBs to air, land, and water. Before we go into the data, let me first make clear what is the situation for the environment agencies in Italy. So we can do the typical technical tasks, so sampling, chemical analysis. We can report and collect data. We support other authorities, but most importantly, what we cannot do, and this is a very bad situation, a problem that has to be addressed in Italy, we cannot issue, not even recall permits for industries. We cannot even issue fines and sanctions. It means that if we find a stake exceeding the limits, we can do really nothing except telling the authorities that we have found somebody above the limits. And we cannot even enforce best available technologies to improve the environmental performances of industries. And this puts us in a very weak situation against, as you have seen, very large emitters. But this is an actual picture of the plant. This is the main stack for the sinter plant, which is the main source of dioxin. Now it is recognized that this is the real main source of dioxins worldwide for emissions to air, this type of plants, of which a few are still active in Europe. In Italy we have 2 of those, but this one is really the largest of Europe. It's the second largest sinter plant in the world, second to a Korean one. So only very recently there were some agreements between the local authorities and the sinter plant to improve the environmental performance. But it was even more recently, only in 2006, that the issue of dioxins emitted was raised. And let me underline this date because the problem was recognized much earlier in Europe, at least 10 years old. So we are late on this issue. But in the meantime, as often happens in Italy, not with the initiative of authorities, but citizens themselves, they put pressure by doing their own analysis. They bought a cheese sample from a local producer, analyzed it, and found it was 3 times above the maximum levels for dioxins and PCBs. And only at this time, just immediately later, authorities, this is Environment Agency, this is the Health Authority, and this is the authority responsible for food and feed. Only at this time, only after that, this finding, we put up an extensive monitoring program. And what we find out very quickly that all the farms around the plant were exceeding the limits. And in a 3 years period, over 2,500 sheep and goats were stamped out. This was our approach. This is in this industrial area. This is a 5 kilometers ring where we concentrated the effort at the very beginning to be as quick as possible. And except one, all those farms were found exceeding. And then we moved at 10 kilometers, then 15 and 20, and found many others non-compliant farms. The outcome of this was, apart from the stamping out of animals, was that now there is a ban on grazing for 20 kilometers around the industrial area. So the public pressure was really increasing against us. You can see here very dangerous, angry people protesting against us. You can see a very black bloc lady here. So the pressure on us was very, very strong. But the first problem we had to face was, what is the emission limit for a sinter plant? And here, believe it or not, in Italy the limit was this one. This is not even TQs. This is as many dioxins as you can measure, and it's 10,000 micrograms per normal cubic meters. Of course, you cannot compare with incinerators because the units are different. But if you convert this, is approximately a 40-to-1 ratio. So this equals to about 200 nanograms per cubic meter. So you can see that this is a limit that is unlikely to be exceeded by any plants, even in the worst conditions. But in the same time, many other European countries, I don't know if this is updated, probably not, because I know that in Belgium is not this anymore. For now it should be 0.4 in Belgium as well. But as you see, many other countries has already set limits for this specific plant. Again, this is a sinter plant. This is the plant where the iron ore is mixed with the carbon and pre-melted to obtain chunks to be fed into the blast furnace. So this is an unusual plant, if you want. But as you see, the consensus was that the limit should be from 0.1 to 0.4 nanograms per cubic meters. So we had this big problem. So we wrote to the Ministry for the Environment. We said we have a problem with this limit. It is useless that we go there and measure the emissions if the limit is of this size. This will never be emitted. There is a problem. The Minister for the Environment did not reply to us. And we wrote even to Italian Prime Minister, at the time was Berlusconi. Again, he did not answer to us, gave no reply, no interest. At the same time, you see, this is another Italian northern region where there is a smaller sinter plant. They could locally enforce a limit, but this was possible because this plant is very small, so the district was responsible for the plant. Since the Taranto plant is very big, the final responsibility was for the central government, so we cannot do exactly the same legally. But the problem was there, and the problem actually did not escape the European Commission, because if you see this report in 2005, it was already noted that there was a problem with Italy, because even if we had a limit since the 90s, it was the total dioxin concentration. And even this report says that even if you take 100, the limit is hardly to be exceeded by any plant. So the problem was real, it was really there. So what we did then, with the collaboration of the local governor, because again we cannot set as Environment Agency emission limits, then we took the initiative, and in December 2008 we set this regional law, and this was really tough negotiation, because as I said, the responsibility was for the central government, so we were afraid that this legislation would be rejected by the central government. And this new legislation set the new limits for these plants in 2 steps. From the 1st of April, 2.5, and from the 1st of January, 0.4, so bringing things at European, at least comparable to other European plants. Of course, this legislation was took very badly from the industries, even for the central government. Now, this is written that the Environment Agency is ruining 3,000 families, because this was the estimation of the jobs that would have been lost because of our more stringent limits. This is my Director General for the Environment Agency, who was accused of ruining the family. Even the Minister for the Environment said that the plant will close in 4 months because the limit was not sustainable. Even if we could show that in Europe the same limit was actually in force, and there was also a problem, as you can see, of unloyal competition, if you want, because if you have a plant that can emit as much as it wants and other plants, then poses also economic problems. But this is the very same Minister for the Environment, only a few months later, we declared the war to dioxin and was pushing this button to start the urea plant. So the industry, anyway, the legislation was in place. It was not rejected by the central government, so they had to adapt to the first step of the legislation, who was 2.5 nanograms per cubic meters. So the first step they took was to implement this urea addition to the feed material. Urea is actually a technology which is well known for incinerators. In that case, this is sprayed as a liquid solution to the waste to be burned. In this case, it's added as a solid to the feed material and has some effect on reducing the dioxin emission, at least by half. So the war to dioxin was declared, and you see that this is a very important thing, because you see the religious authorities, as usual in Italy, when something is very important, they take part to the event. So it was the first step against dioxin. This is finally some data. This is the whole series of measurements we have made starting from June 2007 up to very recently, December 11, and not only for the cinder plant, but also for the other sources. This is a waste incinerator that we can find exceeding his limit, then the cement kiln and another incinerator. But as you can see, we started from this situation. Please keep in mind that this stack, this is the actual stack we are talking about. This is a very high flow stack. This is a 3.5 million cubic meters per hour. So you can see that even this small amount, which is in the latest measurement, is about 0.1. This makes a lot of dioxins emitted per year. So we started from here, and this made 200 TQ per year emitted. We went very well. They could easily adapt to the first 2.5 nanograms emission limit. They had some trouble in the beginning with the 0.4. They could not achieve it very easily. Actually, this was made with the urea and electrostatic precipitator. Then they moved away from urea. They were not happy with results. They moved to carbon injection. But at the beginning, it was not working properly. Apparently, lately, this goes much, much better. But even this small amount, I was saying, with this very high flow of 3.5 million cubic meters per hour, makes still 10 grams TQ per year, which is not negligible. Of course, it is a good result. Let's say a 90% reduction in only 4 years. So that there is some success in here. But of course, to really say that an improvement is made, you also have to measure at the receptor level. Because when you go, you all know that you go on a stack for emission sampling. This is 8-hour sampling. You can even repeat it many times during the year, but it's still very limited for a plant that works 8,000 hours per year. So you really cover only a small part of the emission. And here we can agree that long-term sampling is needed to really assess the performance of a plant. But still, besides the emission, you have to look at the receptor level, how it is going. For example, one indicator could be the dioxin and PCBs in particulate matter, in suspended particulate matter. Those lines are monthly samples. We sample this on small filters daily, and then we pool the samples on a monthly basis, and we come out with an amount in femtograms per cubic meter on a monthly basis. You see the number one is the closest to the industrial area, and we have an urban area and a background. As you can see, some improvement can be observed. Here you have the background station. You can see that it goes really with the season. This is winter, summer, very reproducible seasonal distribution. For the urban area, this is the same. The same seasonality is not seen here, and this is always a good indication that you are close to the emitter, because then the amount does not depend really on the weather, but on the process being emitting in that very special time. So the seasonality is still visible in a way, but not as clearly as here. So we are close to the emitter, which is obvious, but until you don't have the data, it's not easy to tell. Maybe a better way to look at this data is, sorry, this is in Italian, this is the moving trend. Let's say you make every month, you make the average of the best 12 months. And this removes any seasonality in the data, and you can really see just how it evolves over time. So the dioxins are this violet line. We can say that an improvement is made. Maybe it's not 90% as it would appear from the emission. It is more about 50%, but some success were visible. Not the same was for PAHs, which had a peak in 2010 due to process problems. And dioxin-like PCBs had a reduction faster and then went to a plateau. Now, in the very latest result seems to be again on the increasing. But particulate matter is probably not the best indicator in this case, because as you all know, we are not really exposed to dioxin through our breathing. Particulate matter can also go down to the soil level by washout, by rain, but it's not really the way that this enters into the food chain. A better indicator, I think, is to measure the atmospheric deposition. This is a bulk deposition. You have this bottle with a funnel on it, and you expose it to the weather for 1 month, take the sample, and this again, so is on a monthly basis what we measure for the sum of dioxins in deep blue and dioxin-like PCBs in lighter blue. For 3 stations again. The first is very close to the industrial area. This is a farm, just to see if the farms that we found exceeding the limits were really affected by deposition of dioxin. And again, a background station. The red line is quite arbitrary, if you want. Actually, this is not. This is taken from Belgium that has suggested a threshold for the bulk deposition of dioxins to 8.2 picograms per square meter per day. Actually, in Germany, there is another one in Germany which is stricter, and is 4 picograms, so you can imagine a second line here, at 4 picograms square meter per day for the sum of dioxin plus the dioxin-like PCBs. But whatever the threshold you set, you can see that this, very close to the industrial area, is exceeding monthly and systematically this safe threshold. The same is for the farm, number 2, which is in several cases has an exceedance of this level, while the background, this is about 15 kilometers, 12 kilometers actually far from the industries, and you can see this is almost okay with the monthly values. Again, a better way to look at this is the moving average on a 12 months basis. And here again, after a good, this in yellow this time, dioxin, after a good decrease in the first year, then it apparently is not going down anymore. And that's why I am still worried. I cannot tell that the problem was solved by simply improving the stack emission. Because emission from an industrial plant is always to be regarded as a complex event, and emission is not just coming out from the stack, but is also dust, dirty dust that can be resuspended by wind, by meteorological emission, by just moving raw materials. And this is, since this is atmospheric deposition, this goes directly to the ground, this is really what enters in the food chain on grazing field and can expose the cattle and the sheep and goats to dioxin and go into the food chain and get really to us. But some success was evident. But while we were focusing on air quality and emission, it turned out that even emissions to water had done enough damage in the meanwhile. In this area, this is the city again, this industrial area, there is a lot of mussel culture and the production is very intensive. The areas of horizon are this A, B, C, and D in yellow. And since the whole area is part of the Superfund site for remediation, we had a lot of analysis on sediments and mussels to assess the quality of the sea environment. And here again, this is for sediments. As you can see here, industrial area, there is a sort of gradient in sediments going away to east from the industrial area. Of course, the discharge is not only from the steel plant. All other emitters have been discharging for years their waste, the liquid waste to the seaside, especially also the military shipyard here. And this resulted in this situation. These are very high value, maybe not as high as Stefano showed us in the Venice lagoon, but still, we have now a limit of 2 for natural areas. This is exceeded a lot. The 2 is for the sum of dioxin plus PCB, so you can see this is 10 times more, over 100 times over the limit. We have a limit also for total PCB, which is 190 ppbs, which is largely exceeded. And this, of course, the situation of the sediments will be reflected into the mussels. And as you can see, all the samples coming from zone A, which is again the closest to the industrial area, all of the samples were above the limit. Limit is 8. There was not a single compliant sample. Same was for zone C, on this side of the first basin. And even zone D, we had some exceedance. The only safe place looked to be the zone B, which is farther from here, and the zone E, which is is from the other side of the sea. But the problem appeared in all this evidence, and now all the mussel culture here is prohibited, and we are starting the way to how to clean up the site, which will be very, very difficult task. This is a very large area. This is a lot of sediment to be removed or kept or whatever the remediation would be chosen. So, to conclude, what are the hints of success? Because again, I cannot tell of a complete success we had, but some improvement are evident. Well, at least now we have a clear emission limit, and we had to wait 2008 to have this emission limit. It had some effect, at least on air quality. But a more interesting data, which is, nanogram per cubic meters is, as I said, not the real way as we are exposed. We have really to look now, and modern legislation should always keep into account the flux in grams per year more than the cubic meters. So since the flux is decreasing from 200 grams, which is really a lot, and you can imagine this has been going on for 50 years. So you can see the amount that this was accumulated over time. It's decreasing to about 10 grams per year, but this number, in my opinion, is still very high. You know that even a modern incinerator has an estimate of 0.1 grams per year. So this is to be, again, improved. And this has been confirmed by long-term sampling, as I said before. And finally, air quality is showing some progress, but the food chain appears to be still at risk. So here is my co-workers. I want to thank them, and thank you for your kind attention.
but for sure there's more work to do.
Yes.
Are there any questions to Vittorio? Stefano?
Vittorio, have you an idea about the ratio between the flux of dioxin through the scenery and the diffusion of dioxin through the dust?
Yes, we have some idea of this because, as I said, the technology to clean the dust emitted is electrostatic precipitator. This means that you end up with a lot of dust being collected that has to be disposed. So in case of all the dust collected per hour being dispersed, so in even the worst scenario you can imagine, that you take the dust and you throw it away, the ratio will be 10 emitted by the stack, 2 emitted by the dust. And this actually, the message is that the abatement is not effective at all. But the dust, you know, is very highly contaminated, so it's really important that this is disposed properly because it's very extremely high levels.
Yes, but in your opinion, the contamination of the people that live close to the plant is due to the dust or to the emission of the stack that is high 240 meters?
No, it is clearly due, as I said, to the fall down of the coarse and the heaviest dust, which are not emitted by the stack. But actually, the stack is 210 meters. This is not by a hazard, because 200 meters is usually the mixing layer of atmosphere. So this means that if the stack goes above these 200 meters, the plume will never, it can even never go down, except of course when it rains or when the atmosphere is really plugged down. But 200 meters mean that it's going to go to Greece or go to China or go somewhere else. The diffuse emissions, so the dust that's coming out by the wind, this does not travel a lot. So, and we have done even some comparison on congenital profiles. And we have seen that what we found in soils, in grazing soil at the farm level, resembles a lot more the dust collected by the precipitators more than the profile of the congeners being emitted by the stack, and this was a confirmation of this theory. So yes, you're right, the diffuse emission is much more dangerous locally than the stack emissions.
And now the questions. So you reduce the emission. These chemicals, urea, types, can also reduce the concentration of dioxin in the dust, or you need to reduce the dust diffusion?
No, actually, the carbon injection increases the amount of dioxins in the dust, because you're not destroying the dioxin, you're just shifting from the stack to the dust, but it's still there. So the dust is even more dangerous now.